Hello there, and then welcome to a brand new video. This is Happy Beyond Numbers, where we learn maths the easy way. In this lesson, we are looking at parallel lines on a number line. And by the end of this lesson, you should be able to identify the condition for two lines to be parallel. After which, you should also be able to write the equation of a line parallel to a given line and then passing through a number of points. Without much I say, let's quickly look into it. So talking of parallel lines, I have this line over here, you see, and then I have this other line over here. Now we say two lines are parallel if they do not meet. You see, they do not even meet at all. So per our section we have over here, these are two lines, you see, and as they are aligned to each other, they are never going to meet. If I extend this and also extend the other, you realize that they will not meet anywhere. So with that said, there are some characteristics that we need to observe on these two lines that will help us in this lesson. That is, for two lines that are parallel, we would always realize that their gradients are the same. You see, their gradients are what? The same. So if the gradients are the same, then it simply means what? Their angle of inclination are also the same, and we can even test that. So if we had these two lines on a graph sheet, okay, and we want to show that their gradients are the same even without calculating their gradients, then you can come here and then measure their angle, the angle the lines make with the x-axis. You see, so with this over here, you realize that my lines here are making an angle of 60 degrees. And the same applies to this one here. You get it? So that is just the geometric aspect of things. Now let's look at how we solve questions relating to this. Now we know the slope equation of a line, of a straight line, is given as y is equal to mx plus what? C. And for that matter, let's take two lines. So for line one being what? Y, which is equal to your m1x plus c1. Because I'm using line 1, that's why I'm using this one over here. Then for the second line, that is, I'll call it line 2, I would say y is equal to m2x plus what? c2. You get it? So these are two equations of what? Our two lines. Now, if we are really saying these two lines are parallel, you see, so if line 1 is parallel to line 2, then all we are trying to say is m1 is equal to m2. You see that? And if m1 is equal to m2, and they are all the same, then we can rewrite these two equations of the line as what? The same m's. You see, there's no need differentiating their m, which means that if I have this m over here, I can just come and substitute it to this m over here, and then I'm on my way looking for the equation of this line. You see, so to apply all this, let's take some few questions and then see how we can relate these equations and what we've learned here. So looking at our first question here, it says you have to find the equation of a line that is parallel to. So the equation of a line is parallel to this equation over here, and then it passes through this point. You see, so let's look at how we can solve this. Now, if you remember how we find the equation of a line, we said that what we need, what? The gradient of the line, and we also need a point. You see, so x and then y, we need the point. Looking at the equation we want to solve for over here, we have been given a point. You see, so you have been given a point that is 1, 4, but do we know its gradient? That is what we want to determine now. Now, from what we are learning right here from parallel lines, we said that what if two lines are parallel, then their gradients are equal. If two lines are parallel, then their gradients are what equal. So if we come back here, we are being told that the equation that we have to look for the line that we have to look for its equation is parallel to this over here. And that is y is equal to 2x plus what? 3. It is parallel to this line over here. And if you look closely, then the gradient of this line here is 2. So that simply means that its gradient is equal to the one we are looking for. Hence, our m that we want is equal to 2. And that is just it. So all you need to take note is the gradient in this equation over here. Why? Because we've been told it is parallel to the equation or to the line we are looking for. You see, so now that we have the gradient and we have the point, we can then look for the equation of the line. You see, and per our previous lesson on equation of a line, we said we can use the point slope form. That is y minus y1 is equal to m into bracket x minus x1. And we know our m to be what? 2, and then this are our point. So substituting, we have our y minus y1 would then be what? This over here, 4. So 4 is equal to our gradient, which is 2 into bracket x minus your x1. This is the x value you have here. So that is 1. Expanding our bracket, we are going to get our y minus 4, which is equal to, we have 2 and then this here. So 2x minus 2. That is multiplying through. So that making y the subject, we have our y, which is equal to 2x minus 2. Then our negative 4 joins that to be what? Positive 4. And simplifying what we have here, we are going to get y is equal to 2x plus 2. This becomes the equation of the line we are looking for. You get it? And you realize that its gradient is 2. Same applies to what you have over here. You get it? Yes. So this is the equation of the line parallel to what this here, and then it passes through this point over here. Let's look out for more examples. So looking at our second question here, it says you have to find the equation of the line parallel to y equals negative 1 over 2 x plus 5, and then it passes through this point. So this time around, let's go straight to the point since we understand the ins and then the outs. So with this, we know since the lines are parallel, then they have the same gradient. And looking at the equation we've been given here, its gradient, that is our m, is equal to negative 1 over 2. You see, and we already have our point. Our point is what? 2, negative 1. So since we have the gradient and we have the point, using our equation here, which is y minus y1 is equal to m into bracket your x minus x1, where our y1 and x1 are what we have y. So x1, y1. So your x1 is 2, your y1 is negative 2. Hence, substituting, you are going to get your y minus y1. So minus into bracket negative 1, because our y1 is negative 1, which will then give us negative 1 over 2 into bracket our x minus the 2 we have over here, making y the subject. Or first opening our bracket, we are going to get our y plus 1, that is a negative times a negative, which is then equal to your half, negative half times x will give us the negative x over 2. Then we now have the negative half times the 2. That is negative 1 over 2 times negative 2. We know since it's negative and negative, we are going to get a positive. Then this 2 cancels out. this 2 over here, and we'll be left with just 1. You see, so if we evaluate all that, we are getting 1. So plus 1, after which we then try to make y the subject. So you have y, which would then be equal to a negative 1 over 2x, which is the same as negative x over 2, plus 1. And then this one moves to the other side to give us what? Minus 1. You see, so we have y is equal to negative 1 over 2x, because 1 minus 1 gives us a 0. So this here is our equation, or this here is the equation of the line that is parallel to this over here. So that will be it for this lesson, and I do hope you have understood all that we've done so far. All we are saying is, if you have two lines that are parallel, it simply means their gradients are the same. You see, and you know for now that if we want to determine an equation of the line, we need the point on the line and the gradient. So if the two lines are the same, then we can take the gradient from the equation in question. You see, provided we've been given the point through which the other equation passes through. You see, through which the other equation passes. Then in that case, now we have our gradient and you have your point. And using our formula over here, we then solve for what? The equation of the line, as we have done in these examples. As usual, I'll leave you with some exercises to try on your own. So as usual, these are the exercises you can try just to test your understanding. Just 2 sets of what exercises. This first one here, and then this second one over here. I do hope you'll be able to do it. If there's any issue of concern, you can always let me know at the comment section. And if this is your first time on this channel, this is How Beyond Numbers, where we learn maths the easy way. If you have found this lesson useful, you can always choose to subscribe if you so do wish, so that anytime I release the next lesson, you'll be notified as well. Stay blessed and then have a nice day. Bye.